Okay. I think everybody knows that if this coil is oriented this way with the area perpendicular to the magnetic field, the flux linkage of this coil will be NBA. I hope everybody knows that, huh? NBA is the flux linkage when this coil is oriented like this. So the question is, what if it's oriented like this? I think everybody knows that it's either a sine theta or cosine theta. So which one is correct? One way to go about it is to consider that when it's oriented like this, we do not have the whole area perpendicular to the magnetic field. What we have is effectively only this area that's perpendicular to the magnetic field. So if this is area A, what would this area be? Now this is the opposite side of this right angle triangle, right? So you know it's going to be a sine theta. Basically, instead of A, the effective area is only A sine theta. Okay, the other way is to just do a guess and check. So for example, you just make a guess that it's actually sine theta. So the key is when this thing is oriented vertically, we know this term here must become 1 so that the flux linkage becomes NBA, which is what we know is the correct answer, huh? So if this thing were to be oriented this way, what would theta be? 90 degrees, right? So let's put in 90 degrees to check whether what we guessed was correct, huh? So we guess a sine theta. So when the angle is 90 degrees, sine 90 is a 1, which makes the flux linkage NBA, which is correct. Alright, so now we know, oh yes, it's sine theta is the correct one. If we had guessed cosine theta, then at this angle it will be cosine 90 degrees, which is 0. That means we are saying that the flux linkage is 0 when it's oriented this way. Then we know cosine theta is wrong. So we'll go back to sine theta. Alright, that's all I have to say. Ta-ta!